Good morning. Welcome. We are slightly behind schedule because of some technical issues. It was not really standardized, the format today. But here we are, and welcome to this session about the ground model. We do not have a microphone on stage or for the audience, so everybody needs to speak up, as in church, or forever keep your quiet. Today, the ground model, as a part of Eurocode 7, this is the basis. Yes, it's the latest version, verified by Paris. Unfortunately, I didn't put the star of France in IFSTAR's old place. Sorry, Philip, but it's adjusted now. We are, from the beginning, 30 members from 18 countries who have been working for the past couple of years to put together a guideline. And it's representing soil, rock, and groundwater. And it's, as you can see, with representatives from all over the different geological situations. We are not all over the Europe, but we are all over the geological situations. And that's the basis for the ground model. And we have tried, really tried, to have a system that can work independently of the geological situation. And that's a struggle. Yeah, that's difficult. But who are we? I am Håkan Garin, the convener of this task group, also the co-author of Eurocode 7 Part 2, and normally senior geotechnical engineer at a company called the Geotechnical. But today we will also have Matthew Baldwin, independent consultant from UK, talking about the purpose and the process. We have Philip Ravstek, research professor, and also the co-author of Eurocode 7 Part 2. You still remember that, Philip? We have some examples from Christian van den Meer. He will talk about that. He is the technical director for Weitzema and Partners in the Netherlands. And we have about derived values. Robert Woodke from the University in Nordhausen, Germany, will talk about that. But, last but not least, we have the discussion session. We have planned for about 20-30 minutes of discussion, questions, and discussions. So that's the plan for today, and now I will go into and start with a short introduction. This is the table of content in the guideline. For today's seminar, we have scheduled to take care of section 1 up to 5 and annexes. And this is the version that's been submitted to all of you. Hopefully you have been able to download via WeTransfer this one. Sorry, but it should look like this as a working draft. That's what we prepared for this session. Seems to be like I've had some running up the stream because the technical presentation for this part was not on the computer here in the morning either. I don't take it personally by then. But this is the guideline. It will be published in a couple of weeks or within a few months. There are problems before Christmas. That's what's to be. And that is nice to look at. But we will take care of these parts of table of content today. But the ground model, what's that? Ground model is in the zone of influence, a site-specific outline of the disposition and character of the ground and groundwater based on the results from ground investigation and other available data. That's direct from the definition of Eurocode 7 Part 1. That's the definition of ground model. It should be enough, because that's what it is. That's the definition. But there is a variety over Europe how the ground model does look like. So bear also in mind that we are talking about ground investigation, and ground investigation is not only field and laboratory works, according to Eurocode 7, next generation. Ground investigation is the desk study, the site inspection, field and laboratory test, monitoring, etc. So it's just more than just the field and laboratory work, because that's the field investigation and the laboratory investigation. The ground investigation cover much more. So, but ground model is not a new concept. No, it's not rocket science. But what it's new in Eurocode 7 perspective. So what's the ground model? It's the first idea. I had a discussion with a couple of colleagues in the Nordic Geotechnical meeting a couple of weeks ago, and they asked, what's the ground model? When a colleague or a client calls me, at the same time I got the email or the telephone or WhatsApp, whatever, I start thinking, where are we? What's the geological conditions? That's my left brain. And at the same time, the right side of the brain is starting, how I'm going to be able to bill these hours to the client as a technical consultant. So it's, yes, that's the half of the brain. Immediately starts with the ground model. I think you have the same feeling. You need to know where the project is. And you need to have a project, otherwise you don't start the ground model. So, it's a philosophy to assemble the ground model. It's not a straightforward box to work with, but it's a mindset. The ground model is not a product. It's a way of working at the same time. Of course, you need to have some outcome from the work with the ground model, but it is an ongoing work. As we in this group say, it's a train. It continues going, and you fill up the cars on the way. But you have to start with the idea of how the train will be filled up in the beginning. So you start with the experience you have from the area. You develop it by having a desk study and a site visit. And do not forget the site visit. It forms the basis for planning of the field and laboratory work. You verify it afterwards, or during the execution, or during the assembling of the ground model. You need to have it verified. Otherwise, it's just a theory. And you establish an updated version of the ground model. And you end up, this is probably the layout, the figure Adrian van Zeters intended to show in the opening. This is the layout. I think you will see it once more again during this morning hours. So you need to have an anticipated model before you perform any kind of field and laboratory works, because you can only test to verify, and that's my philosophy. You have to have an idea, verify, or take it away by the test. You can't find the layout of you can find the details of testing, of course, but the overall picture, you can't just go out and do this field and laboratory works and say, this is the ground model. I'm sorry, I think that you will be lost in the model at that time. So, Matthew will take us through the process, just a couple of minutes. And that's the part for that one. So these are the parts, and we have the ground model and the geotechnical design model. In this piece, of course, we have a lot of jumping around to end up with a verified model. And then we end up with the geotechnical design model at the end. So you develop it over time. The output, yes, you can have it here, normally not in Latin, but as a simple text. That's also a ground model. 1D or 2D, yeah, sketch, cross-section, that's also a window into the model. And you can have what I call 2.5D or 3D, that actually be a computerized model to make it possible. And Christian will take us through with an example how the output might look like in the end. Documentation. Of course, you have to document what you are doing. As engineers, we like that administrative work very heavily. Not all of us are fancy of doing the administration, but Eurocode 7 requires it. The ground investigation itself, zone of influence, derived values, model uncertainties, and ground model validation ends up to be documented either in the ground investigation report, which is the primary source according to Eurocode, or in a geotechnical design report, which is an option in Eurocode 7 Part 2. And Robert, you will assist us with derived values. And Philip, you will also take us through a little bit about corresponding uncertainties. And uncertainties not only related to derived values, but to the model itself. So that's the end of the introduction, and I say thank you very much, and I hand over to Matthew to take us through the process. Thank you.